Okay. Good evening. Can you hear me? Can you hear me? Yes. Okay. Okay. Thank you. Okay. What we discussed last day? We discussed about, yes, Fleming's law, Fleming's right hand law and Fleming's left hand law. Yes. Okay. This is the final part of the electricity lesson. Our today lesson, transformers. Transformers. Okay. Let me open our tune. Electromotive force, then Kirchhoff laws we discussed uh, last week, and previous day we discussed about Fleming's law. This is our final part of the lesson. It is transformers and electricity bill calculation also I hope to discuss today itself. Okay, this is a Fleming's right hand law. What's the purpose of Fleming's right hand law? To find the direction of the right hand law, current direction. To find the direction of the current direction. Okay, left hand law, what's the purpose? To find the direction of exerted force direction. Exerted force direction on a magnetic field. In Fleming's right hand law, find the direction of the current, the indication current in a magnetic field. Okay, I think you can remember the dynamo is, according to Fleming's right hand law, dynamo and alternator. They are producing energy, electricity, current. But in Fleming's left hand law, when it's provide electric current on a magnetic field, what happens? A force is exerting. This force direction we can find by Fleming's left hand law. Fleming's left hand law, and the how to calculate the force magnitude? Do you remember, Tanya? How to calculate this exerting force on the magnetic field? How to calculate this direction? Okay, direction you can use Fleming's left hand law. How to calculate the magnitude of the force? I told the equation. What is the equation? What's the equation? Quickly. What's the equation? Yes, F equal BIL. Very good. F equal BIL is the equation. F equal BIL is the equation. F equal BIL. F equal BIL. Okay, this is the force, the magnitude of the exerted force. Okay, what's the meaning of F? That's a force. What's the meaning of B? Magnetic flux density. That's measured by Tesla. The Tesla is the unit. I, the current flowing through the conductor. L, the length of the conductor. The length of the conductor. I told electric magnetic flux density increasing, current increasing, and length increasing, all factors directly proportional to the exerted force. That's why magnetic flux density BO, current increasing, it's highly cost work, right? It's highly cost. Now current increase karna api loku power ekak dendo. It's highly expensive, but without expensive, we have a chance to increase the length of the conductor. Motors and fans, that's why they used copper coil inside the fan. Inside the fan, copper coil ekak demma. What happened? We can increase the length of the wire conductor. Okay, we can increase the length. The fan is made by, okay, this is the copper coil is used like this. Coil එකක් තමයි use කරලා තියෙන්නේ. Between two SN in magnets that's connected to a battery. Okay, this is a simple fan. This is a N and this is a S magnet. Now what happened? Always what is the magnetic field direction? N to S or S to N? N to N, N to S or S to N? Magnetic field direction always N to S. Very good. This is the magnetic field direction. This is a magnetic field direction. Now current, what is the current direction? Magnetic field direction N to S. What's the current direction? This is last lesson. I'm revising. Samia, what is the current direction? Positive to negative or negative to positive? Current direction. Current direction. Current direction. Positive to negative or negative to positive? Current direction. Very good. It is positive to negative. Positive to negative. This is a positive side. This is a negative side of the battery. Then the current is flowing this way. This way. This way. This is a current path. This is a current path, right? I told according to Fleming's left-hand law, now a current is flowing through a magnetic field. Then what happened? A force is exerted on the conductor. Force exerted on the conductor. What happened? Fleming's left-hand law. This is a magnetic field direction. This is a magnetic field direction. If you go this side, the current is flowing to upward. What happened? Inside to both, a force is exerted into this direction. Inside to both. A force is exerted. Okay, same method, Fleming's left-hand law. This is a magnetic field direction and this is a current direction. You can see into on this side into outside to both, a force is exerted. Okay, now I told those two forces are couple of force, same magnitude, opposite direction, and they are acting on two lines. This type of forces we called as couple of forces, and that's the mechanism of a simple motor. Understood? That's I already explained for. This is the direction. Okay, according to that, the fan is rotating into this direction. Fan is rotating into this direction. This is the fan rotating direction. Okay, can you suggest any method to increase the rotating speed of the fan? Any suggestion? What do you think? අපිට increase කරන්න ඕන නම් rate එක or speed එක, what we can do? Joel, any suggestion? Fatima? Yeah, we can increase the number of turns on the copper coil. Oh, very good. We can increase the current, but it is expensive. We have to spend more for electricity. But that's the easy method. හරිද? අපිට ගලවලා මේ coil එක වෙනස් කරන්න බෑනේ. That's the easy method. What we can do? We can shift it to next level. In fan you have 3 to 4 levels. We can increase the level. Level එක increase වෙද්දී මොකද වෙන්නේ? What happened? The current is increasing. Current increasing, what happened? The fan speed increasing. Understood? Clear? So if you fan galawala නම් කරන්නේ, we can change the all methods. Okay, we can increase the current, the speed increasing, that's a very easy method. We can increase the number of turns in the coil. Or we can change the two magnets into high magnetic field, magnetic with high magnetic flux density. Okay, they are the options. Understood? I think you got the full story. Amina, understood? Okay. Okay, that is from last day lesson. Okay, our today lesson, transformers. Transformers. Okay, what are the transformers in your village? I think you have seen transformers, no? Transformers. ඔයාලා දැකලා තියෙනවා? Okay. Okay, what is the purpose of transformers? And what are the, how we can prepare a transformer? What are the types of transformers? Okay, they are the things we are going to discuss now. Okay, transformer is a device that reducing or increasing the voltage of an alternative current. Alternative current. Alternative and direct current I will explain. AC and DC. Alternative current mean AC. Direct current mean DC. Normally, if you got battery or something storage device, that's always provide direct current. I will explain the difference in final part. If you got plug and the normal electricity, it is always alternative current. Alternative current. And if you got battery, that's direct current, DC. අපේ මේ wiring system එකකින් එන්නේ normal electricity එකකින් එන්නේ alternative current. Okay, what's the purpose of the what's the function of the transformers? Reduce or increase the voltage of any current, alternative current. Increase or reduce or change the voltage of any alternative current. That's the purpose of transformers. Okay, how to prepare these transformers? It is very simple structure that we called as laminated core. Laminated core is a number of plates that we called as laminated core, and it has two coils. This we called as primary winding or primary coil. Primary winding. It has number of turns. This number of turns very important. I think you in all level time you did that. The number of turns very important. Okay, that we called as secondary winding, and this is we called as primary winding. Okay, this primary winding number of turns and secondary winding number of turns, that depend. This is what's the type of this transformer. Okay, I will explain. Oh, sorry. Okay. Okay, first one. Typically, one coil of a transformer is connected to a AC source. AC source means direct current. AC current. and the second coil connected to a load. That means whatever device. Okay, this is a primary coil. Normally, the primary coil connected to a AC current. The primary coil connected to AC current. This is a AC current. The AC current supplied to the primary coil. Then what happened? The secondary coil connected to whatever device. The first coil is supplied electrical energy into transformer is called as the primary coil or input coil. Yes, that we already discussed. Primary coil or primary winding. Okay. The coil that extracts the energy is called as secondary coil or output. That's a secondary coil or secondary winding. The input is a primary always. The output is a secondary. Okay, that's output is a secondary. The input always primary. Remember, the alternating potential supply to the primary winding is called as VP, and the potential coming out we called as VS. That means, okay, transformers. I will simply explain. That is very simple part. Transformers. Okay, this is the that we call as laminated core. Laminated core. This is the shape that we call as laminated core. Okay, this is a winding, the primary coil or primary winding. The number of turn of this winding, that is very important. Always this is the input or AC current. AC current means alternative current input. AC input supplied to the primary winding. Okay, that's a primary coil. Okay, the output or the device is connected to a secondary coil. The device is connected to a secondary coil that we called as output. Remember, the primary coil voltage or potential difference between primary coil that we called as VP. Voltage of primary coil. Voltage of primary winding. Okay, this is a primary. This is a primary. This is a secondary. Okay, remember voltage of secondary coil or potential difference of secondary coil we called as VS. Up to now, okay? VP and VS. Joel? Understood up to now? Okay. Now, okay, I will explain this equation after this type discussions. Okay, normally transformers mainly two types. What's the meaning of normally transformers mainly two types? Okay, what are the types? Step up transformers and step down transformers. Okay, what's the meaning of step up transformers? Okay, step up transformers always increase in the voltage into lower voltage to higher voltage up to higher voltage of alternating current. Increase the voltage. Remember, step up transformer is a type of transformer that increase the input primary voltage into a higher output voltage. I got how to increase that. The number of turns in secondary coil is greater than the number of coil in primary coil. Okay, this is the okay. Now transformers, that's the basic structure of the transformers. Now transformers we can divide into two categories. Transformers we can divide into two categories. What are the types? Step up transformers and step down transformers. Step up transformers and step down transformers. Okay, what's the meaning of step up transformer? The voltage increasing. That's a simple meaning. The voltage increasing, the voltage of primary coil. That means VP. Sorry, voltage of secondary coil. VS is VS greater than the VP. That's the meaning. I think now you can understand. VS greater than the VP. How to increase secondary coil voltage? It's increasing the number of turns in secondary coil. That's the meaning. Okay, think this is a primary coil. This is a primary coil. That's a VP. Primary coil. That's a secondary coil. That's a VS. This type step up transformers, the number of turns in secondary coil is greater than the primary coil. I got the point. That's why the voltage of secondary coil is greater than the primary coil. Done? Understood? Tanya? Clear? That's a step up transformers. Step up transformers. Okay, the number of turns in secondary coil is greater than the primary coil. That's a step up transformers. Okay, if you got yeah, this is a story. As we saw, the secondary voltage is higher than the primary voltage. Yes. Step up transformers are widely used in power transmissions. Yes. Normally, when we produce energy in power plants, electricity power plants, that increase into higher voltage, increase up to higher voltage to reduce the current, hereby minimizing energy loss during the long distance transmission. Actually, that's the purpose. This step up transformers used in power plants. Api hadana electricity එක we can convert into higher voltage. Normally, what is a transforming mean transmission voltage in Sri Lanka? Transmission voltage is Joel. How about the transmission voltage from power plant? From power generation plant. What's the transmission voltage? Habib. What's the transmission voltage? Sometimes it is 33,000 volt. 33,000 volt. Sometimes it's double. 66,000. 66,000 volt. Okay, they are the transmission voltage. Why we increase the transmission voltage? To reduce power loss. To reduce power loss or electricity energy lost. To reduce energy lost, we use higher voltage by step up transformers to convert the. I got the point. Now in power plant produce whatever energy amount, electricity energy, that we convert this electricity energy, convert into higher voltage like 33,000, 66,000. Okay, then transmission through transmission systems. Okay, in this transmission by 33,000, 66,000 high voltage, we can minimize energy loss, we can minimize power loss. Okay, I will explain how to reduce this power loss while transmission this type higher voltage. I will explain. Okay, can you understand? That's the purpose of step up transformers. Okay, let's discuss about step down transformers. What's the meaning of step down? Opposite side. The voltage, the primary voltage is greater than the secondary voltage. Voltage drop into normal value again. From transmission system, transmission wires again convert into normal voltage. Normally in your village, වලගේ ගම්වල තියෙන ගොඩක් step down transformers. Not only all transformers in your village, they are step down transformers. 33,000 voltage converted into 230 volts. That's the purpose. 3,000 voltage 230 ගන්නවා 230 වලට ගන්න. Okay, that's a step down transformers. Okay, that's a step up transformer. The primary coil, secondary coil number of turns in greater than primary coil. Okay, step down transformer is a type of transformer that reduces the input voltage into lower output. Voltage drop. In these transformers, what's the method? The number of transformer, the number of turns in primary structure, that's a VP, is less than, sorry, VP is greater than the VS. Okay, that's a step down. Step down. Number of turns in primary coil is greater than the secondary coil. Okay, that's a short note of the lesson. That's a short note of the lesson. As a result, the secondary voltage is lower than the primary voltage that we discussed. Step down transformers are commonly used in power supply systems. For example, to high transmission voltage, that means 33,000. As I explained earlier, 33,000 higher voltage into lower voltage required for household users and industrial users. Yes. Normally into your village, how to transfer energy as 33,000 volt. It's a higher voltage. ඒ වගේ voltage එකකින් තමයි ඔයාලගේ village එකට ගේන්නේ. I got the point. You can separately identify how these systems. අර උඩින්ම තියෙන ඒවා තමයි 33,000 කියන්නේ transmission system එකේ. හරිද? 33,000, sometimes it is 66,000 transmission systems we used to long distance transmission. After that, in your village, what they doing? This 30,000, 6,000 convert into 230 voltage by step down transformers and distribute into houses. Understood? Okay, that's the shape of step down transformer. Primary coil number of turns is greater than the secondary coil. Okay, are you good up to now? Any doubt you can ask? Any doubt? Samya, understood up to now? Step up transformers and step down transformers. Step up transformers used in transmission system, long distance transmission systems. Power plant to long distance transmission system use step up transformers. Normal voltage convert into 33,000, 66,000 higher voltage for reduce energy loss. Step down transformers in your village, what they're doing, these higher voltage again convert into normal 230 voltage and distribute into homes, houses. Got? Jod? Sarmya? Tanya? Dihini? Okay. Okay. This is an example. That's a very important example. Okay, I told in they ask him to write Fleming's left hand and right hand laws. No. Then directly what is a law definition not asked up to now. But it is very simple, no? When we place those three fingers perpendicular to each other, this is a magnetic field, force and current. That's only. But it is easy. You can write in your word. In left hand rule, left hand, middle finger, index finger, and thumb finger keep perpendicular to each other. The index finger show the direction, sorry, magnetic field direction. Middle finger show the current direction. The force induced direction given by the thumb finger. That's all. In your word, you can write. Don't worry. Okay, තියෙන විදිහටම ඕනේ ඇත්තටම. You have to explain the key concept. You have to mention all three fingers keep perpendicular to each other. That's compulsory. එහෙම තියාගත්තොත් this is a current, this is a magnetic field, and this is a force. That's only you need to explain. Okay. Okay, that's the thing I explained in long distance transmissions. Long distance transmission. Suppose we want to transmit 1000 kilowatt. 1000 kilowatt is electric power. Okay, electric power over a long distance using a line of resistance 5 ohm. Normally, the transmission conductors has some resistance, no, some disturbance that we already discussed, has some disturbance. Okay, now think at low voltage. Now 1000 is a volt. 1000 is a volt. I equal P over V. Okay, what is a P? Power 1000. 1000 watt. Sorry, 1000 kilowatt. Then it is converted to watt. Then divide by voltage 1000. Now, how about the current flow into this? 1000 ampere. How about the power loss? How about the power loss? Okay, I'll show this. Make it, but I'll take it and I will show this. Okay, now this is example. Look, now this is a long distance transmission system. think the power of electric power production, the power of the power plant, 1000 kilowatt. According to this example, it's 1000 kilowatt. Now we are going to transfer this power by conductors with resistance 5 ohms, 5 ohm resistance, 5 ohms resistance. Okay, now we can calculate the I, the current flowing through this path. What's the current? PV equal VI, no? PV equal VI, PV equal VI or IV. Let's say it is VI, P equal VI. Now, if you got I, what is the equation? I equal P over V. I equal P over V. I equal P over V mean I equal, what is the power? What's the power? 1000. 1000 kilowatt. To convert into what I am going to get? Another three zeros. Okay, what is the voltage of the system? Okay, now transfer as 1000 volt. The voltage equal 1000 volt. The system voltage equal 1000 volt. Voltage equal 1000 volt. Okay, how about the transmission system voltage? 1000 volt. Okay, think 1000 ampere transformer. 1000 ampere transformer. Okay, according to power equation, we can calculate the power loss. We can calculate the power loss due to resistance. Power loss equal PV according to P equal VE. Sorry, P equal VI. අපිට තව equations තිබ්බ නේද? Last day I explained. Instead of V, I'm going to use IR. Then what is the equation? P equal P loss equal I squared R. Because P equal, instead of V, I can substitute IR into I. What's the equation? I into I squared R. Okay, power loss equal the power loss due to resistance of the conductor we can get by the resistance of the transmission system. We can calculate by P loss equal I squared R equation. Okay, now what is the I squared? I squared equal 1000 into 1000. 1000 into 1000 into 5. Okay, it's a huge value. What is the value? Yeah, this is a value. 5 into this much of power lost during the transmission. This is a power lost. Power lost. Loss is even greater than the power we try to set. Actually, if we transfer as 1000 volt, no any power is remain. Maybe loss is even greater than the power we try to set. That means no any energy transfer to your village. If it is transferred as 1000 volt, 1000 volt එක කෙවුවා නම් මුකුත් ඉතුරු වෙන්නේ නැහැ. Can you understand? Dehini, could you got this? Could you get this? I calculated by using 1000 volt. Power loss is greater than supply voltage. They know anything remain. Habir got? Fatima? See, try to transfer 1000 kilowatt, but power loss 5000 kilowatt. 5000 kilowatt is a power lost, but only supply 1000. එතකොට පොඩි දුරක් එද්දි මොකද වෙලා තියෙන්නේ? Yeah, no any power remain when it is transferred long distance. Okay, but if we can increase using a step up transformers, if we can increase the voltage, into higher values, see, make here that, let's say 100,000, like 100,000 volt. Okay, if you use 100,000 volt, the voltage equal 100,000, 1 lakhs, 100,000 volt, 100,000 volt. Okay, what is the current flow into this? Current equal I equal P over V. What's the P? I equal 1000 into 1000. That's a power. Divide by V. Now V equal 100,000. 3 to 3 cancelled. 10 ampere is the I equal 10 ampere. Okay, that's why I was told when we can increase the voltage into higher values by step up transformers, we can reduce the current flowing. We can reduce the flowing current. Now the I equal 10. Now power lost, P lost equal, what is the equation? I squared R. Now what is the value? P loss equal I squared means 100, no? 10 into 10 into R. What is the radius? The transmission radius, sorry, not radius, resistance. Transmission resistance not changed in the same transmission system, 5. How about the power lost? We can't stop power loss. If you want to stop power loss, we have to use zero ohm resistance conductors, transmission systems. But in practically, we can't find 0 ohm voltage, 0 ohm resistance power transmission system. Every conductor has some value resistance, right? Some disturbance. Therefore, we can't stop, but we can reduce the heat loss by increase up to higher voltage using step up transformers. Now it is only 500 watt. How much we transmit? 1000 kilowatt. Only 500 watt is, yeah, it's like a magic, right? Only 500 watt is the power lost. We can transfer without loss 900, 500. Yeah, sorry, 950 kilowatt we can transfer. No, 999.5. Yeah, more than 999 we can transfer. Yeah, lost only 0.5 kilowatt. 0.5 kilowatt. Okay, understood? Amina? Fatima? Dihini? Okay, that is the reason always we use high voltage for transmission purpose. for transmission systems. Others, Tanya? Understood? Okay, that's the final part we are discussing electricity lesson. Okay, understood, right? Joel? Hi. Okay, let's move into final part. Yeah, power loss only 500. That's already given. 500 watt. 500 watt means 0.5 kilowatt. No, 0.5 kilowatt means 999.5 kilowatt we can transfer. Where loss is very small compared to transmitted power. Transmit करे कोई 1000 kilowatt. Loss only 0.5 kilowatt. It's a very negligible value, no? But how we got this very small loss? By increasing the voltage up to higher voltage. By increasing the voltage up to higher voltage. That's why we got lower power loss, very small power loss. Okay, normally in Sri Lankan condition, we are power transmission system increase up to 33,000 voltage. 33,000 voltage. 33,000. 33,000 watt. Now 33,000 watt. 33,000 watt. Now 1000 over 33 is the answer. 1000 over 33 mean what's the value? 1000 over 33. Can you send it? Thousand over 33. In Sri Lankan condition, I am calculating. Abir, what is the value? 1000 over 33. 30.3. Okay, approximately think it is 30. I got the approximate value, whole number. Now power equal I squared R, no? I squared means 30 into 30 into 5. Okay, what's the power loss? 3 into 3, 9. 9 into 5, 45. 4,500. What is the power loss? Okay. In Sri Lankan condition also no more issue, right? When we this is 10 millions, no? 10 millions watt dwelling, 4,500 only lost. Okay, that's not a considerable value. But if we can increase in Sri Lankan condition, we only increase up maximum 66,000. A local transmission system, maximum 66,000. But into your village, I think they use normal systems, 33,000. 33,000 volt transmission systems. 33,000 means some මේ වගේ value එකක් තමයි 10 million වලින් plus 10 4,500 watt per 10 million, not 10 million, 1 million. Million making 4,500 plus 10. Okay. Okay, that's the transmission system, the actual story. This is a power plant. This is a power plant. Now it is produced 12 kilowatt. Now this is a step up transformers that increase up to higher voltage, 4,000 kilowatt, 400 kilowatt. Now in village, they use step down transformers, again get into 13 kilowatt and 240 voltage using step down transformers. Okay, that's the story of the actual system. Okay. The ideal transformers. Ideal transformers. Okay. They are the actual practical transformers. Ideal transformers, not practically actual transformers. Ideal transformers mean theoretical transformers. Remember, ideal mean remember theoretical. ඒක actually නෑ මේ වගේ. මම කියලා දුන්න මාල් theory. Actually don't have ideal transformers. Okay, let's see what are the ideal transformers. Ideal transformers is a theoretical transformer that works without any energy lost. Okay, anywhere in practically we can't find transformers without any energy lost. Any transformer they have energy lost, but this is a theoretical assumption. Okay, we thinking. Okay, we think transformer no any energy lost. If it is the same concept as perfect transformers, ඒකත් වෙන වචනයක්. හරි. The ideal transformer is the word. The perfect transformer also the transformer without any energy lost. That means when while voltage convert into high to low or low to high, no any energy lost. That's the meaning. But there is energy lost. No energy lost. Characteristic of ideal transformer, it don't have energy lost. That means efficiency 100%. No resistance. Yes, I told in practically we can't find no resistance compound, but we assume the ideal transformer don't have resistance. No linkage or flux. Magnetic flux produced primary passes through the secondary. If it has magnetic leakage, it's energy loss. Okay, no any leakage, no any current lost or any other type or statistic lost. Okay, now the ideal transformers. Understand, ideal transformers, that's fully theoretical concept. Okay, ideal transformers, we can't find any ideal transformers practically. We can't find. Okay, that's full theoretically assumption. Ideal transform. Ideal transformers. Okay, what's the meaning of ideal transformers? Transformers without any energy lost. Okay, think this is the transformer. This is a transformer. This is a primary winding, primary coil. Okay, this is a power of primary. This is a power of secondary. Okay, what do you think? This transformer, step up transformer, step down transformer? What do you think? What do you think? Step up or step down? Quickly. Sadmia? Step up transformer, step down transformer? Fatima? Step up or step down? Definitely. That's step down transformer. Okay, according to ideal concept, ideal transformer, no any energy lost. No any energy lost mean, what's the meaning? The energy supply to the primary, winding equal to, that means P primary equal to the output energy of the power of energy. No, power primary equal to power secondary. Power secondary. Okay. Now this is ideal concept, ideal transformer. That's a fully theoretical concept that I always explain. That's a fully theoretical explain. In practically, we can't find this type transformer. Okay, every transformer has energy loss due to resistance of the coil. Okay, according to that, P equal VI, that you already know, right? P equal VI. We can say primary voltage VP, primary voltage into primary current that we call as IP. VP into IP. And we have opposite side secondary voltage, secondary current. Okay, we have special equation now according to ideal concept. VP IP equal VSVP. Sorry. Correct. VP IP equal to VSIS. Understood? Okay, the same thing in O level. In O level, you learn this like this. The same equation. This is a basic equation and concept. ඔයාලා O level වල මෙච්චර දැනගෙන හිටියේ නෑ මොනවද ඔයාලා දැනගෙන හිටියේ? In O level time, you did the same thing like this. VP over VS equal IS over IS over IP. Understood? Okay, that's a basic concept of transformers. Okay, that's the basic concept of the transformers. VP IP equal VSIS. According to this concept, we can get our equation. Both the equations are same thing. Understood? Understood. Tanya? VP over VS equal IS over IP. Yeah, it's another one. Yo, then make කරන්න. No, it's another one. මන්තා මෙතෙන්ට ආවේ නැහැ. Yeah, in Tute, that's another one. මේක තියෙන්නේ නම් this is NS. අපි මේක NS use කරේ නැහැ නේද? This NSNP mean number of turns. ඒක මම කියන්න. That's okay. Okay. I am explaining this equation. According to ideal concept, VP equal, that means primary power equal to the no any power lost. Primary power equal to the secondary power. That means VP over VS equal IS over IP. This is the equation. Make it possible. Okay, Joe? The primary equal to power in the secondary. Okay, that's the ideal concept. Okay, instead of that, addition, voltage ratio equal to the turn of ratio, then we can say VP or VS over VP equal to the NS over NP. That's another concept that's given in the previously also. Yeah, in this part also I given this part, this equation, right? Yeah, this one. NP over NS equal to VP over VS. That means the voltage ratio that is equal to the number of turns ratio, number of turns. Okay, now we have two equations. Equations according to ideal concept. Okay, if you the basic equation first, the number of turns and voltage. The number of turns voltage, Vp over Vs. That's very simple equation. Equal to Np over Ns. It is same ratio. Same ratio. Pp Ns. Okay, if you got this in opposite direction, make opposite with Np over Ns. This is the final equation you need to remember. Vp over Vs equal to the Is over Ip. That's the final equation, the summary of the full equations you need to remember in transformers. Okay, that's a very important point. The number of turns and voltage, it is same, primary, but for current it will be changing. The side changing. The current of secondary coil. Understood? Yeah, this is final. You can write down. Now okay, Joe? Dehini, Tanya, Fatima, Habir. Only for current, the primary and secondary will be changed. For number of turns and voltage, it is same ratio, but for current, it will be changed. That's only you need to remember. Okay, go to tutorial number 1. Tutorial number 1. In your TUTPAC tutorial number 1. In your TUTPAC tutorial number 1. Electricity tutorial number 1. Okay, a perfect transformer. A perfect mean ideal. A perfect transformer connected to a 240 voltage supply and have a current of 0.1 ampere flowing in the primary winding. If the output voltage of the secondary winding are 12 volts, what is the current in the secondary winding? Okay, quickly calculate. What's the current flowing through secondary winding? What's the current flowing through secondary winding? Okay, done. Quickly. Okay, others, Kabir, Fatima. Okay, what is the equation now? Dihini, what is the answer? Fatima, check again. Check again your answer. Okay, a perfect or ideal transformer connected to a 240 voltage supply and have a current of 0.1 flowing in the primary winding. Okay, now what is the equation? I want the relationship between ideal transformer relationship of voltage and current. Current and voltage, then power equation, right? Power, primary winding power equal to secondary winding power. Okay. However, now Vp Ip equal to Vs Is. Okay, according to our equation, we can say primary voltage given 240, 240 into the current 0.1, 0.1 equal to the secondary voltage 12, 12. Is don't know. Is don't know. Is means secondary current is asking. The current of the secondary winding. IST. How to calculate? 240 into 0.1 mean 24. 24 equal 12 Is. Then Is equal 2 ampere. 2 ampere answer. Fatima, you sent answer number. Correct, correct. I told 4 amperes. Correct, correct. Answer number 4, 2 amperes. Okay, question number 2. A perfect transformer, ideal transformer has 100 turns in the primary and 200 turns in the secondary. When the primary is connected to 120 voltage and the current of 10 ampere obtained, what is the voltage and current on the secondary? Quickly calculate. Take only 2 minutes. Good question. Okay, a perfect transformer has 100 turns in the primary and 200 turns in the secondary. Okay, if you want for easy calculation, you can write like this. Now, the given data you can write in symbols. Okay, 100 turns in primary, that means NP equal 100. NP equal 100 like this. NP equal 100. NS equal secondary number of turns 200. 200. Now, when the primary is connected to a 120 volt, that's in primary voltage PV, sorry, VP. VP equal 120 voltage. Next, supply and the current of 10 ampere is obtained. Then IP also given. IP, the current of the primary winding, 10 ampere. That's a given data. That's the given data. What is the voltage and current on the secondary coil? Okay, first of all, you can find the voltage, right? How to calculate voltage? NP over NS equal VP over VS. Voltage and number of turns ratios same. At the P udata gathot, both if you got NP, the VP in same side. Same side VP. Okay, now you can calculate NP equal 100, NS equal 200 equal VP equal 120, then Vs. Now 0 to 0 cancel. Now Vs equal cross multiplication to 40 volt. To 40 volts. To 40 volts. To 40 volts. Now the question asks, what is the IS, the current? Okay, what is the method? What's the method? V P over Vs equal current opposite equal IS over IP. IS over IP. Changing, okay, direction changing for only for current. Okay, VP equal 120, Vs equal 240 equal IS don't know, IP given 10 ampere. Okay, 0 to 0 cancel. 120 IS equal 120 over 224. 120 over 24. 120 over 24. It's 5 ampere. 5 ampere and 240 voltage. 240 voltage and 5 amperes. Answer number 1. Okay, they are the exam type questions. Okay, sorry. Okay, that's the end of theory part of the uh, electricity. Okay, we have another part, the electricity bill calculation. Several time in exam essay questions also given this question, electricity bill calculation. Okay, take a paper and write down the topic, electricity bill calculation. Electricity bill calculation. Okay, after this part, any past paper or any electricity question, you can complete. Now you have three tutorials. Three tutorials. This is tutorial number circuit tutorial we discussed. That's Kirchhoff flow tutorial we discussed. No, that we completed. If you want, you can try this again. Same paper, you can same questions you can try, and you can. I'll give you another questions. First, you have to complete those tutorial. Tutorial number 1, I have given practice questions part by parts. It has 18 MCQ questions and more than 50 essay questions. No, not essay type, but practice type questions. Part by part, I have given, and Fleming's law applications examples. In tutorial number 2, I have given they all are past paper questions. Past paper questions on electricity lesson. Tutorial number 2. You have to complete. Okay. Tutorial number 3, past paper essay questions in exam. Past paper essay questions. Separate. Okay, you have 1 week. You can complete all. If you have any doubt, you can ask next week. I hope to spend 1 more week, 25th week also, 25th of March, February also, to discuss advanced difficult parts of electricity. And I hope not, sorry sir, not 25th. 25th we have to start new lesson, statistics. We have to get extra class on Friday, this Friday. Okay, I will arrange and schedule extra class, on this Friday. Okay, Friday same time, to discuss the advanced questions of electricity. Advanced questions mean Kirchhoff law, Fleming's law, everything, mixed questions, exam type questions we can discuss and complete the electricity lesson. From next Wednesday, we can start our new lesson, statistics. Statistics, it's a very important lesson. You know, in exam, it's a compulsory essay question in 2015 to 2025. 11 papers, 11 exam papers, all exams, all past paper, the first essay question based on statistics lesson. Okay, that's very easy. Then make a, you can bring these marks into from your home. Okay, wala gathering aragena anupula marks tikak tiyenne. Very simple lesson, but you have to 100% complete and confident in this lesson. Without confident, you can't. If it is a complex question, little bit advanced questions they ask, you will not become, you will be confused and panic if you're not confident. Every lesson you have to prepare very well and make your confident level. That's very important to answer in exam without any doubt or panic. Confident for all lessons. For that, in my side, I have complete 100%. Sometimes more than 100% in all lessons. Okay, electricity bill calculation. electricity bill calculation. Okay. Normally, how to measure the power? What's the unit of the power? Tanya, what's the unit of the power? What's the unit of the power? Power. Tanya, what's the unit of P? Unit I want. Dini, what's the unit of the power? Very good. Watts. Watts. Okay, we have very simple equation. We have very simple equation. Do you remember P equal VI? P equal VI. P equal VI. What is the method? What's the meaning? The power equal current into voltage. P equal current into voltage. P equal current into voltage. That's what very important. Sorry? P equal current into voltage. P equal VI. Now, if I got E or energy equal, do you remember last week I explained? E equal PT, P multiplied by time. Or we can say E equal VIT. VI mean P into T. Okay, they are the very important equations. P equal VI, E equal, that's mean the amount of electric energy, energy equal PT or VIT. PT or VIT. PT or VIT. Okay, in electricity bill calculation, remember what is the unit of energy now? According to this equation, what is the unit of energy? Energy unit. What's the energy unit? Power unit watt. Power unit watt. Power unit watt. Time unit seconds. What seconds? What seconds we called as joules? What seconds we called as joules? But in electric energy calculation, electric energy measurements, the industrially used unit, industrially applicable unit is electric energy. Electric energy. That's the used unit. kWh is a unit. The same thing. The kWh is the unit. What's the meaning of kWh? Anyone? That's called as kilowatt hours. Kilowatt hours. Watt seconds I have modified into kilowatt hours to measure large electric energy. अब लोगों එකක් මනින්න අපි use කරන kilowatt hours. Kilowatt hours. Remember then what is the electricity unit එකක් කියලා අපේ form එකේ මයින්නේ මොනවද? 1 kilowatt hour. Electricity unit එකක් කියන්නේ. Remember in our home electricity unit එකක් කියන්නේ electric unit. That means 1 kilowatt hour. 1 kilowatt hour is the electric unit. Okay, up to now, okay. Please note down these things. Make a short note. That's the meaning of kilowatt hour. That means 1 kilowatt hour. kWh1. kWh1. One kilowatt hour called as 1 electric unit. Complete. Joel. Complete. 1 electric unit equal to 1 kilowatt hour. 1 kilowatt hour. Then, okay, let's do an example. Okay, in your home, okay, tell me what are the electric devices used in your home? Okay, this is the device. This is the power. This is the time. 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 Okay, this is question number 1. Question number 1. In a particular home, they are the electric devices they have used. Okay, first, they have used 10 bulbs. 10 bulbs. Per one bulb, then what? 60 watt. 60 watt bulbs. 60 watt bulbs. Time 8 hours per day. 8 hours per day. Okay, that's a type of exam question. Okay. And it has the house has 3 fans. 3 fans. 150 watt. They use 4 hours per day. 4 hours per day. 4 hours per day. And one electric kettles. One electric kettle. Electric kettle. Kettle. 1500 watt that use only for 15 minutes. 15 minutes per day. And one rice cooker. Rice cooker. Rice cooker, 2000 watt. That's only used for 20 minutes. 20 minutes per day. And let's take another one. And phone chargings. Phone chargers. Phone charger. Phone charger. Only one phone charger. It has 20 watt. 20 watt up to 3 hours, no? 3 hours. 3 hours. Okay, they are the electric devices used and their powers, their power values and time consumption for the usage. Okay, now I am going to calculate the electricity bill for this day. At the Medium-Tharaka 30 days. This is per day. This is per day usage. per day usage. Oh, say, okay, this is a usage per day. If you want 1 month, then month, this day value per month, this day value you can multiply by 30. This is a per month calculation. Okay, the day consumption multiplied by 30. This is a monthly consumption. Hard. Then, okay, first of all, you can okay, I'll take more space for our calculation. Okay, this is a okay, first of all, I'm going to calculate the 10 bulbs, 10 bulbs, 10 bulbs, 10 bulbs. Okay, how to calculate? Its power 20 watt. What is our equation? E equal Pi. What is the P? 20. 20 given in watts. 20 given in watts. Okay, first of all, you have to convert that into kilowatt. 20, sorry, 60 over 1000. 60, not 20. 60 over 1000. That's for one bulb. That's multiplied by 10. 10. Because 10 bulbs multiplied by time. 8 hours. 8 hours. That's per day. To get into month. Okay, අපි days වලට හදාගෙන යමු. Days. Okay, then 0 to 0 cancel. 0 to 0 cancel. 6 into 1, 6. 6 into 8, 48. 48 over 10. 4.8 kilowatt power. Kilowatt hours. I got. Understood? Dehini? Sarmya? Understood. Then device usage, I just want to convert into kilowatt hours. Kilowatt hour, kWh. Then that's a one, that means for only for bulb per one day, 4.8 kilowatt hours usage using this home. Next, tree fans. Tree fans. 150 voltage. Sorry, 150 watt. To convert into kilowatts, 1000. Three number of fans. Three number of fans. How many hours? 4 hours. Then what is the kWh value? 0 to 0 cancel. 15 over 3, sorry, 15 over 4, it is 60. 60 over 16 to 3, 180. 180 over 100, 1.8 kilowatt hours. kWh 1.8. 1.8 kilowatt hours. Okay, next, electric kettle. Electric kettle. Electric kettle. Electric kettle. Okay, it is 1500. 1500 to convert into kilowatt divide by 1000. It is only one device. Only 15 minutes. 15 minutes mean how many hours? Kabir? 15 minutes. What's the number of hours? Very good. 0.25 hours or 1 over 4 hours. 1 over 4 hours. Okay, 20 cancel out. 15 over 40. 15 over 40. 8, right? 15 over 40, 0.375, right? 0.375, good. Sorry, 0.375 kWh. Very simple. මේ විදිහට ඔක්කොම හදාගෙන යන්න තියෙන්නේ. Same method. Okay, phone charger. Phone charge. What's the watt? 20 watt. Convert into kilowatt. 1000. Divide by 1000. Only one charger. They have used 3 hours. 0 to 0 cancel. 6 over 100, 0.06 kilowatt hour. Okay, that's a method. Okay, now you can convert. Now you can convert monthly consumption. Sorry, not monthly. Per day, how many kilowatt units used? Kilowatt. Sorry. Rice cooker also there. Rice cooker. Rice cooker. 2000 watt. 2000 watt means 2 kilowatt. 2 kilowatt. Only one. How many hours? 20 minutes. 20 minutes mean? 20 minutes mean what is hours? Yeah, 1 over 3. Because per 1 hour, 1 over 3. Then 2 into 1 into 1, 2. 2 over 3. 2 over 3 mean? Samya. 2 over 3 mean? 0.66. 0.66 kilowatt hours. Okay, now you can get the summation of the day consumption. Okay, now you can get per day electricity usage. How to calculate at these all values? Okay, what's the summation? 4.8 plus 1.8 plus 0.375 plus 0.06 plus 0.66. 7.695 is the daily consumption. 7.695. 695 kilowatt hour. Kilowatt hour is the daily consumption. Okay. Now think. Okay, write down everything. Okay, now think. Okay, before write down, please ask. Now think per 1 kilowatt hour, that means per 1 electric unit, the electricity board cost or electricity board charge 20 rupees per 1 kilowatt hour. Electricity board charge 20 rupees. 20 rupees. Now you can calculate the monthly electricity bill. How to calculate? 7.695 per day. Then monthly consumption, you can multiply 695 into 30. What's the value? Multiply by 30. Use calculators. Kabir. Kilowatt hour is the kWh is the 230.85. Yes, kilowatt hour is the monthly consumption. Okay, now you can monthly rental or monthly electricity bill. Monthly electricity bill. You can calculate that can be changed. Okay, that's I got example that can be changed. The 1 unit price can be changed according to current situation. Okay, now 230.85 multiplied by 20. Okay, this is the monthly electricity bill. Monthly electricity bill 4,670. 4,617 rupees. Okay, note down. Okay, complete. Samya. Okay, okay, note down. Fatima, complete. Okay, now okay, Salmia. Tanya, complete. Okay, now you can start. Yeah, they are the homework today. I told to get printouts of past papers. No? Okay, now I hope you all have past papers. You can now you can do. Especially you have to complete 2015, 2015. Wait, I can't remember the 2015. This is electricity question. Okay, this is the question. This is a question. Full question now you can. Full question එකම කරන්න ඕන. Is it taken at the tutorial tree? No, it is not given in tutorial tree. It's a separate question. Okay, now you have huge homework lot today. Okay, I'll explain one by one. Please note down. Homework godak, you have only 7 days, not 7 days. You have only 2 days. Before Friday, you have to complete. This is a homework number 1, 2015, question number 9. Essay question number 9. Note down 2015 A level paper. 2015 A level essay question number 9. Question number 9. Next, electricity tutorial number 1. Electricity tutorial 1 practice questions. Electricity tutorial 1 practice questions. And electricity tutorial 2. What are the questions? Past paper questions. MCQ past paper questions. Electricity tutorial number 2. Okay, you have huge work load. Finally, electricity tutorial number 3. You have more than 200 questions actually. Okay, electricity tutorial. She don't need them. You have two days after Friday. You can go to tutorial number 3. Okay, They are the task. You have 2 days. වැඩ කරන්න මේ lesson එකේ ටිකක් you have to work hard for this electricity lesson. Okay, that's a homework. 2015 essay question number 9, electricity tutorial number 1 MCQ, electricity tutorial number 2 MCQ. That's all. Within 2 days you can complete. Okay, any doubt? That's the end of electricity lesson. Let's discuss the questions on Friday. Any doubt? Electricity, any? Now you can ask. No? Dihini? Fatima? No doubt in electricity? Okay, you have to practice. You have to keep practice for this lesson actually. If not, it will be forget all Kirchhoff law, Fleming's law, Ohm's law. ගොඩක් තියෙනවානේ. It's a bulk lesson. You have to keep practicing always. If you complete the lesson, you have to keep practice until the exam. At least 1 to 3 days, you have to again go through and revise it. At least one time per week. Take 30 to 40 minutes. You have to go through again and revise. If not, this Kirchhoff law, Ohm's law, Fleming's law, they are very important for exam. Therefore, you have to again and again keep in touch with them. Okay, no issue, right? Okay, then the electricity completed. Let's start next week. Statistic cover, new maths lesson. Okay, goodbye, good night. Please go to complete homeworks.